bestrobo.in, your favorite robotic and electronics store in India.
Hello everyone, welcome to Infratech. Today in this section we learn about ADXL335 sensor, that is accelerometer sensor. This is mainly used in order to measure the accelerometer or tilt sensing. So this is how ADXL335 accelerometer sensor will look like. So it mainly has 5 pins, as you can see. 5, this is VCC in order to provide power supply, ground button. Next we have X out, Y out, Z out. This is, it will give acceleration due to gravity in all the three different axes: X axis, Y axis and Z axis. So this the ADXL335 is a small and a low power, a complete 3-axis accelerometer with signal. So it can measure the static acceleration of gravity in tilt sensing application, as well as a dynamic acceleration resulting from motion or shock or vibration. So it can mainly measure the acceleration due to gravity in all 3 different axes. So this is the working mechanism of the ADXL335 accelerometer. So initially it will be in this condition. As you can see, there will be like fixing plate. Inside that it has a moving plate or mass, and that is in between the fixed plates, and there is a spring in it. So inside that it has a capacitor. So whenever there is some due to some vibration or pressure, like whenever an acceleration is applied on this moving plate, the moving plate will move. At that position the capacitor values will change. Depending on the capacitance value change, it will give us the acceleration values in acceleration due to gravity values in all the 3 different axes. So as shown in the figure like that, how it mainly consists of fixed plates and moving plates. So acceleration deflects the moving plates and unbalances the differential capacitor, which results in a sensor output voltage amplitude which is proportional to the acceleration. As I told, like this this acceleration ADXL335 sensor will work to the phase sensitive demodulation technique that is used to determine the magnitude and direction of the acceleration. So what are the technical details of this ADXL335 sensor is, it has a length of 19 mm or like you can get 0.75 inches, and width of 19 mm, height of 3.14 mm, and a weight 1.27 gram weight it has. So what are the application of this ADXL335? You can make use of this ADXL335 in order to measure the acceleration due to gravity in all 3 different axes. In tilt sensing applications you can make use of this accelerometers. So accelerometer has a wide spectrum of application, from a smartphone to aircraft. Like in a smartphone, like in order to you can in a tilt sensing application in the smartphone, like when you are using a phone, it will automatically depending on the position of how you are holding mobile, it will go from a portrait mode to landscape mode, like that. In order to do that, we are whatever the sensor we are using is, that is that is accelerometer sensor only. And the accelerometer are boon for smartphone, as I told. And accelerometer is used in aircraft also in order to measure the several parameters to stabilize the flight. It is used in digital camera for optical image stabilization. It is used in electronically stabilized tripods for photography professionals. So next we will see how to interface this ADXL335 accelerometer with Arduino Uno microcontroller. So it has mainly 5 pins, as I told. So VCC we have provided to connect it to 5 volts of Arduino Uno in order to provide the 5 volts power supply. Next, ground I connected to ground pin of Arduino Uno. Next, it has 3 pins, X out, Y out and Z out. These are the things which will give the acceleration due to gravity values of 3 different axes. This I have connected to X out to pin number analog pins, that is, as it is giving the analog values. Analog pin of Arduino Uno, 1 pin number A1, A2 and A3 I have connected respectively X out, Y out and Z out. So this is a simple connection in order to interface this ADXL335 accelerometer to Arduino Uno microcontroller. Next we will see how to program it. So as I told, I am connected to pin number A1, A2, A3, that is X pin, that is X axis pin, Y axis pin and Z pin. After that we will set up the baud rate, serial dot begin as 9600. Next, in the loop, as it has to continuously read the data, acceleration data, so I am using in the loop. So I am seeing the output in the serial monitor. So I am using serial dot printf. First I am printing the X value. So serial dot printf analog read, as it is giving the analog values, I am using this analog read command. So analog read of X pin. So whatever the pin number X pin, that is a pin number connected to A1 of Arduino Uno. From that pin I am reading the sensor values, that is acceleration due to in the X axis. So that I am printing. After that I am printing the same in the Y axis, analog read of Y pin, similarly analog read of Z pin. After that I am printing in the serial monitor, and then I am giving a 500 millisecond of delay. So if I execute this code after dumping into program, the sensor will continuously read the acceleration due to gravity values from the surroundings, and it will give print the values in the serial monitor. As you can see, this is how my output will look like. So it will give analog values of acceleration due to gravity in all three different axes: x-axis, y-axis, and z-axis. Like that, you can easily interface this ADXL335 with any microcontroller like Raspberry Pi or Arduino Uno or any Arduino related microcontrollers, and you can measure the acceleration due to gravity. This can be used in different applications. So thank you for watching the video. Thank you.